Hello, everybody. Hi, everybody. Welcome to the Learning Circle for Tuesday, the 6th of June, and acknowledgements of country from Wajak in Perth. Is there anybody else that would like to acknowledge where they're from?
I would like to say Yuma from Ngunnawal country in the ACT.
Thank you. For anyone else, you can put that in the chat. I would like to now introduce our key speaker for today. Somebody that I've known over a number of years. David Wood is a former education and school administrator and physics teacher. In retirement, David works in a voluntary capacity to represent the Science Teachers Association of Western Australia on the Einstein First program. David's interests and expertise include school leadership, reform and improvement, curriculum reform, education program design and implementation, and advancing the science, technology, engineering and mathematics in schools agenda. We call it STEM. David grew up on a dairy farm in regional WA and studied physics and education at UWA. So for the first 20 years of his working life, he taught science, physics and chemistry in several regional and metropolitan secondary public schools, and was science head of department for 10 of those years. During this time, he was involved in several curriculum reform initiatives. For the next decade, he worked in education administration, a range of senior curriculum roles in the WA Curriculum and Assessment Agency and Education Department, including leading the reform of the senior secondary physics course, managing a review of gifted and talented education in WA public schools and statewide curriculum reform. Since 2000, he held 3 key leadership roles: Foundation Principal of Sevenoaks Senior College, CEO of the WA Curriculum Council, and Chief Learning, Teaching and Innovation Officer with Catholic Education in WA. Throughout his working years, he has maintained a close association with science teaching and the Science Teachers Association of Western Australia. Since retiring, though, he has taken on various roles with STAWA, including with the UWA-based Einstein First initiative. He is one of the chief investigators with a focus on strategic matters relating to the development and implementation of teaching and learning resources, advising on strategies that will ultimately see the Einstein First initiative influence the teaching of physics and earth and science and space sciences in schools nationwide. So I would like to welcome David to the A2 Learning Circle. Climate Science and Sustainable Education, Energy Education is the title. And over to you, David, to start to let us know what that's all about.
Thanks, Jennifer. And I had my little acknowledgement there, but I wasn't quite sure because I'm normally Noongar country, but I'm over here in Sydney. And so I simply said we should all just acknowledge and be very grateful for the wisdom and the contribution that Aboriginal people make to this wonderful country, and for sharing their knowledge and understanding of country. Just very quickly, the Einstein First is a team of people led by David Blair, the whiskered one in the middle, and we've got a number of young PhD students, which is fantastic. We have David Tregest, who Jennifer talked about as a member of he's one of our chief investigators, and others who I might just touch on as we go through. The purpose of this workshop is simply to share the work that we are doing around climate science and sustainable energy futures, particularly around the year 6 level, but acknowledging that this is a theme that we hope to carry right through our programs. The question about why we are doing this is really a bit of a a no-brainer for all of us. We have this inevitable global warming that is primarily caused by build-up of carbon dioxide and other gases in the atmosphere, and the inevitability of having to move to an economy where we reduce carbon, hopefully to zero. Our belief is that children and young adults learning climate science and sustainable energy production will inspire and empower them to understand their science and scientific and technological world, and as a result, invest themselves in the sustainable energy future. So if we just go on the agenda that I'll run through, and this will be we'll make it a fairly informal kind of a discussion as we go through, given there's not a large number of us. This idea of empowering students is a very important one in our mind, and central to why we have included the climate science in the program. The resources to support the development of student knowledge about climate science, climate change, and the need for a sustainable energy future, and then discussion about the resources. And then the future action, what I really hope for, and this would be great if for the whole network, is to, if any schools are keen to work with us to take up the climate science, sustainable energy resources that we are developing, and start teaching them, particularly in year 6 to their kids, but also into year 8, 9 and 10 as we develop our secondary programs, then we would love to hear from you. Just a little tiny bit more background about Einstein First, and Viv, you'll learn a little bit more about this next Tuesday evening, but it's come out of, it's really, I've got 10 plus years, it's probably more like 15 years now, research and 3 ARC linkage grants led by Professor David Blair. David is a gravity waves researcher, spent his whole research life looking for gravity waves, and so when they detected them about 8 years ago now, it was like the culmination of a life's work for him. But throughout that period, he's always had this great interest and desire to contribute more broadly to science education. He established the Gravity Discovery Centre north of Perth at Gingin, and then of late, with this project, he recognised that within the school curriculum, most of what we teach kids around the physical sciences, and physics in particular, is predicated on pre-1900 physics, so what we call classical physics. And he thought it was about time we introduced more modern, what we're calling Einsteinian physics concepts into the curriculum. And so he's worked with all of his PhD students, and mainly through incursion programs, to develop up lesson ideas that could ultimately be mainstreamed, and that's what we're up to now. And so we're developing curriculum. We have got training programs. We've got in primary schools in WA, we've got about 30 schools actually implementing the year 3, 4 and 5 programs. And in secondary, it's a little bit lagging, but we've got about 4 or 5 secondaries involved in the program. So the program itself, what we do, this slide tells a fair bit of the story. We introduce kids as early as year 3 to atoms and photons and phonons. So at the moment, the Year 3 curriculum specifies that we've got, we teach kids about a very introductory chemistry module and about heat. And so we've rebadged these, if you like, atom frenzy, in which we introduce atoms, molecules, the makeup of atoms, the fact that molecules are two or more atoms that stick together, and that those bonds are, you can feel the electrical forces of attraction between them. And then phonons is just simply the heat vibrations on molecules and atoms vibrating. And then in Year 4, we look at heat, look at forces, and then light and photons, which of course is really critical in the alternative energy world. And then we move into introducing the idea of momentum. And of course, photons, light and photons have momentum, and that leads us to solar panels. And then we go into looking at in Year 7, in Year 6 we introduce climate, and then in Year 7 we look at gravity and black holes, and then into Year 8 it builds into energy. We introduce some of the quantum ideas, and then in Year 9 we start looking much more at the dual nature of light and the quantum nature of everything, really, of atoms and molecules and matter generally. And then into Year 10, which is really where there's specification of climate science in the Australian curriculum, is really only formally presented or introduced in Year 10. And we also talk about the cosmology and planetary science and so on in Year 10. So that gives you a bit of an overview of what we are hoping to inject into the curriculum. We have a bunch of principles of pedagogy or learning, if you like, and these are very practical and straightforward. The first is that each of our learning experiences begins with an activity. David says activity first. If it doesn't have an activity leading it or introducing the idea, then it's not us. So activity led. We're using toys and models and analogies and basically very simple, buy it at Bunnings or Red Dot or Kmart, or and so to give you a simple little example, our analog for photons, we use Nerf guns, where the Nerf gun is obviously the light source and the Nerf bullets are our photons. And those Nerf bullets have got wave properties and particle properties, and they have momentum that then transfers, and that can collide with electrons and bump them into higher energy levels. And of course, you're getting the drift of where we're going with this. So then we go also into whole body learning, so little plays and dances and all sorts of active learning for the kids. Making sure that the language is appropriate for the year level that we're working at. Some people look horrified and go cross-eyed when we talk about teaching kids in Year 3 about atoms and molecules, but we do it at a very practical, pragmatic, hands-on, concrete kind of level, using tennis balls with magnets embedded in them, and seeing how those tennis balls can stick together and how they're floppy, and how if you get two oxygens and a carbon, that makes our carbon dioxide molecule that's floppy, and so we go on with the story. So then I've said most of this gear is inexpensive consumer level equipment, and we have role plays, and David's a great one for singing for kids' songs and remembering, really engaging through that, even though he's just about the worst singer that I've ever heard, and that's I'm a shocker myself. So, but he certainly really engaged at that level to make sure we get the level of delivery right for the kids at the particular age group they are. So, just a little tiny bit more about this idea of Einsteinian physics. As I said, it's not that complicated. There's two sides of it. There's the Einstein's relativity theory, which is all about gravity and black holes and warping of space-time and that side of it. And then there's the other side, which is the quantum world. And we say, well, what did Einstein have to do with the quantum world? Well, he got his Nobel Prize for identifying that light comes as both waves and particles. And he also, some of his early work was based on the analysis of Brownian motion, which for the biologists will recognise that. And he used that to essentially prove the existence of atoms. And then he was quite instrumental in the next 10 or so years of his working life, working with all of the great quantum pioneers to develop up what we now understand as the quantum nature of basically everything. So this is really the broad picture. This was done by this little image, was produced by Sean Bublil, who's one of our PhD students. He's almost finished his write-up now. So, but that gives you, sort of encapsulates the scope of what we are doing. Now, let me just go straight into now. I'm going to jump over this because I think it's important that we go straight in and look at the climate science side a little more. So to lay the foundation, we teach kids atom frenzy and hot stuff, and then may the forces be with you. And then in year 5, fantastic photons and our place in the universe. And then in year 6, we've developed up what is essentially an introduction to climate science, and secondly, our sustainable electricity or energy future. That bit of it fits beautifully with the electrical energy part fits beautifully with the existing curriculum. Climate science is a total, wedge in that we are needing to do into the curriculum in year 6. This is probably the biggest fudge that we're doing in terms of matching to the Australian curriculum. These, as I said, these two, the atom frenzy and hot stuff, match exactly with existing year 3 Australian curriculum module. Year 4, there's a forces module that may the forces be with you, meshes exactly with. Year 5, we've got the fantastic photons and the study of the solar system, if you like. And both of those are existing curriculum. So the only thing that we're really struggling with is how to fit climate science in to the year 6. And then in year 7 and 8 and 9 and 10, we've got a gravity module. We introduce the energy in year 8, the quantum world in year 9, and the cosmology and climate change, which again are precisely matched with the existing Australian curriculum. So this question about climate science, why have we decided to go all out, stick our heads out and say we believe that all kids in year 6 should be familiar with the basic science of climate and understand that it is all science that is quite straightforward, and if they've covered the little earlier modules, should be quite comprehensible to them. So we're saying that where we introduce these ideas, we can then consolidate within this climate science module. And that's the, I've gone backwards one. And so the reason why we're doing this is really, again, very straightforward. In WA, we had a parliamentary inquiry that AAEE presented at as well, but it was quite an interesting process. And it highlighted that even though there's lots of things happening piecemeal, there's virtually nothing in the formal curriculum sense to teach kids about climate and climate change. And so that again gave us a little bit more enthusiasm to sort of follow this line. We obviously have our national and international obligations to meet our climate targets. We recognise, and this came out of the inquiry, we recognise that our kids, our children and young adults are those who are going to be most severely impacted by the climate change, simply because they're going to be around a lot longer than many of us are. I've got to be very careful about how I say that. And then we also acknowledge that schools are in a unique position to effect change. So what we're saying there is, by teaching the kids these basic ideas and developing these skills around, I guess, working to mitigate against climate change, then the kids will then influence their parents and their grandparents and all of the community. So it's really a process driven from the base. And we've already seen that with a lot of the marvellous work that's done through environmental education groups generally and sustainability groups, the impact that kids in schools can have on changing the attitudes of parents and adults. And then the final thing is, we've had these couple of reports, one global one a couple of years ago, and then just earlier this year, a national one that came out of Melbourne, that acknowledged that students' climate change concerns are real, that we have this thing called climate anxiety. And we figure that by empowering kids through knowledge, it will, in a sense, act as almost as a vaccination or inoculation against climate anxiety. So the idea that if we empower young people through knowledge of climate and climate change, and the knowledge of what they need to do to change things, then that will make them feel less anxious about the impending doom and gloom that we read about all the time in the paper. So that's really the motivation. Now I'd like to give you maybe 5 minutes, no more, and then we can just chat after that. An idea, these are some of the ideas that we talked about. So these are the tennis balls that we talked about with magnets embedded in them. We've had these made in one of Jyoti Kaur is a PhD person from India, and she had a connection there in tennis ball manufacturer, and we've talked them into embedding magnets into these tennis balls and then using them as our little, what we're calling tatums. And then the hydrogen atoms are much simpler. They're just a little tiny magnet embedded in a ping pong ball. So they're our little atoms that we talk about, and then we can then go and we make molecules, and the kids can feel the what are we doing here? Might be on a timer, where the kids can feel the bonds, so you can feel the binding energy when the molecules, or when the atoms come together to form the molecules, and then you need to do work or put energy into the system to break the bonds. And so that's really the simple level of the chemistry that we deal with. We've done electrical forces in year 4, and so the kids know about electrical forces. We don't distinguish between electromagnetic and electrostatic. We just say electrical forces, and that's in fact true. There's magnetic effects and static effects in bonding in chemistry. So we're not stretching the truth at all for the kids. So they get this sense of a very simple view of chemical bonding. And then where do we go from here? What's going on here? What have I done? And then with our photons are very simple. We talk about photons having waviness and bulletiness, the wiggly shape, and the blue tack weight. The blue tack weight gives it the momentum, and that's the bullety part. And the waviness is, as is obvious there. And we talk about the different wavelengths of the different colours of light, or different coloured photons. And then we also talk about these invisible photons, which of course are the infrared, and they're much less bullety, but they've got a very long wavelength. And that's a particularly important feature of them, because they vibrate at a similar kind of, or the vibrations at a similar kind of frequency to the natural vibration frequency of carbon dioxide and methane and water molecules. And so that's the fundamental cause of our global warming. Now, we then go into, and I'm just about there, we then go into the lessons. And so I've said this before, our lesson 6, we build on atom, frenzy, and hot stuff, and then may the forces be with you, and fantastic photons from year 5. And so we have very simple little activities. These are just to give you an idea of how simple it all is. The top centre is a very simple little activity that we've cooked up, where you just put a weight, like a heavy nut or a washer or something, on the end of a bit of cotton or string or wool, and then you tie it to a pen, and you slide the pen along the top of a desktop. And if you slide it slowly, the weight simply just follows along backwards and forwards. If you wiggle it very quickly, the weight stays almost stationary. But if what we talk about, the Goldilocks frequency, but if you just do so it's just right, you get the movement coincides with the natural swing of the pendulum, then you get this build-up of energy. And of course, that's what happens when carbon dioxide is subjected to infrared. The certain good and methane and the other water vapor, the other greenhouse gases. And so you get this high level of absorption, but almost immediate re-emission of the energy back into the atmosphere. Half goes up and half comes down. And of course, the half that comes down is what's contributing to the global warming. The other little activities are very simple. I don't know if you are familiar with hotties. Someone asked me about hotties, and I didn't know whether to get embarrassed or ask what the hell they were talking about. But essentially, I didn't know about these until a few months ago, and lo and behold, it's brilliant. They're little bags of iron with some other activation agents in it. You then can put this in the top of an inverted jar, and that's just like the good old-fashioned burning the candle one that we all learned about, but it's so complicated. The chemistry and the physics of it is so complicated that it's almost impossible to explain. Whereas this one, the iron particles in the bag simply absorb the oxygen out of the air, and the water comes up to it, and it's pretty good. It's around, lifts it up about 20%, which is about the percentage of oxygen in air. This other one here is nice little activity that David cooked up. My idea of a nice activity around coal was to get a bit of coal and get kids to look at it under different magnifiers. And David thought that was a ridiculously boring idea, and he was probably right. And he said, what about we get a match or a kebab stick, wrap it in foil, and then put just a little birthday candle, and heat the wood underneath the foil. And what we do is drive off the volatiles, of course, out of the wood, and you see them come steaming out the end. And then when you see them start to steam out, it lights up, and that's showing. And then when it's all done and dusted, you unwrap the alfoil after it's cooled down for a few seconds. It's really quite, very small amounts. If the kids are silly, they'd burn themselves. But if you get them to put it on a saucer for a few seconds, it cools down sufficiently, and you unwrap it, and you see that it's turned into carbon. So what we're doing there is showing how to produce how coal is made, in a sense. It's really the pressure, the plant materials that were buried, heated, the volatiles driven off, and the carbon is left behind. So that's our little activity to give kids an understanding of coal. And there's other activities as well. Now, I think I've done enough talking there. This is just the year 6, where we're getting real size solar panels with the electric drills, 12-volt electric drills. Again, very safe. There's no chance of the kids electrocuting themselves, and you can see the energy from the sun being converted directly into electrical energy that is then used to lift up weights and do all manner of things with these little electric drills. So that's kind of gives you a very quick overview of the kind of activities. I've just tried to give you a bit of a flavour there. And what I'd like to do now is maybe just get out of this. How do I get out of this? And so we can come back to where we are. Stop sharing. Where's that?
If you just go down to the bottom to the share screen and say stop.
I'm in my presentation. So maybe I need to escape from the... there we are. And then I go... I'll close out of that. Oh, it doesn't matter. We're right anyway here. Okay, so so there we are. That gives you an idea. Now, hopefully, Viv and Laura, you got an email from Jennifer this morning with the links in to the curriculum resources.
Yes. I must admit, though,
now,
I haven't done my homework.
No, don't worry. I didn't expect that you would have done. But
I'm a naughty girl.
No. I was probably a naughty boy for not getting them through earlier. But the bottom line is that the resources that are on the website, there's this module, Year 6 module that we've developed. It's around about, I think there's 16 lessons there. They start from very introductory climate science stuff that we all did when we were kids going through school, that doesn't seem to be taught now in the same kind of way. So that, and then we've got fully blown set of lessons around that. And then we've also created this thing called Lessons in a Nutshell, which is really probably the simplest way to go into it. And those I think just about any primary science, Year 6 primary science teacher could look at those and relate to them. And embedded in those, we've got little instructional videos and all of the links that we've got through to the digital resources. So that's kind of where we are. And if we could find a couple of schools to have a bit of a crack at this in the different states, we would dearly love it. That's essentially what we're hoping for. We've got in WA, we've probably got about, I had a workshop similar to this about a month ago, and we've probably got about 6 or 7 schools that are really quite keen. So if there was a way of getting the word around, feel free to share the resources and the access to it.
So what age ones are you wanting? So
this is specifically year 6.
Year 6.
Yeah, no. So you'll see at the launch on next Tuesday, Viv, that we're really wanting to recruit schools from year 3 to year 6, and then year 7 to year 10. However, for the climate science bit, the climate science module is specifically targeted at the year 6 level. Okay.
Right. Okay.
So have you got any questions about it before we...
David, are you able to have a go at unsharing? Because
unsharing. How do I go at unsharing? Let me just get out of this PowerPoint thing. I'll close out of that.
Done.
Share screen. Okay. Did that do it?
Yes, thank you. Laura was coming to our rescue there.
Okay, beautiful. Excellent.
Thank you. David, are you happy to take some questions?
Yeah, of course. That's what I was hoping would happen now.
Thank you.
Yep.
So does anybody have any? Yeah, Laura, thank you.
Yeah, thanks, David. That was really interesting, and it sounds like such a great program. I'm an environmental educator, so unfortunately, I'm not a year 6 teacher, so I can't help you with that part. Sorry, but
you're in Perth, aren't you?
Yes, I am. Yeah.
Yeah. Yep.
But yeah, really, really fascinating. I was wondering, I have a couple of questions. One of them was just curious about the research side of the whole program, that you guys have the ARC linkages, and I'm just curious what kind of research projects you are doing with it. And then the other question was just around, you spoke about climate anxiety, and I wonder if any of your programs give the students some actions that they can
So let's deal with that one first. What we're hoping will happen, and this is all, as I said, it's very new, and what we're hoping is that we get 3 or 4 schools come on board who are prepared to have a go at writing like an integrated program that would work over the length of year 6. In other words, have a thematic approach that would work throughout year 6, culminating in kids doing their sustainable energy future stuff probably in term 4, and having a lot of kind of open-ended activity-based learning within that. But in the earlier terms, be introduced to the basic science. I'm old-fashioned enough to think that we need to have a bit of a solid basis of the science before we actually feel really empowered about understanding what we've got to do to change things. In other words, why we have to decarbonise, and what we've got to do to go about that. And it's very clear, the solar energy side of it is really in its many different guises. I mean, not purely photovoltaics, but the whole mix of pumped hydro and all of that those kind of solutions. So that is really where we're hoping that we can go with the schools bit. Now go back to your first part again. What was that?
About the research sort of project.
Oh, the research bit.
Yeah.
Yes. So in WA, when universities or when anyone does research, you're probably aware that there's all of this ethical stuff that we've got to go through. I've got to be very polite. I've described it in all sorts of different, not very flattering kind of ways, but I understand the absolute need for it. And so we've got all the ethics clearance through the education department in WA and Catholic Ed in WA. Independent schools all do their own make decisions individually about clearances. It's probably similar in the other states. Is that the same in ACT, Viv? Do the department have
Sorry, what was the
ethics
question
clearance?
again?
If you're doing research, you have to get clearance from the education department.
Yes.
Yes, so it's the same. I think it's probably consistent across all of the states and territories. So we have that. So if we're going to do research in eastern state schools, then we're going to have to, embark on some kind of way of getting either talking to their education department people and say, this is the pile of bureaucratic stuff that we had to deliver to the education department here. Will you take that on face value and give us approval to work with, A and B school kind of thing? So we'll just restrict it to, the schools that want to be involved in the research. The other thing is just come on board and don't be involved in the research and just give it a go, give it a crack. I mean, it fits well within the scope of the curriculum, except for this year 6 bit. I think it's a bit of a stretch. I think it also fits beautifully with the department's new sustainability framework, which is really, it's a national sort of move as well. So, yeah. Has that answered both of those?
Yeah, no, that's great. Thank you for that. Yeah, and
Good.
I guess I was curious with the research, like, are you looking at things like, does the students' knowledge improve, or their attitudes towards physics and things like that? Or
yes, yeah, that's so the aim of the Einstein First, and this is again David Blair's kind of original thinking, is that much of what we teach kids in primary school and probably lower secondary as well, because it's all predicated on pre-1900 physics, and the kids in their real world know all about photons and phonons and gravity and warp space-time and black holes and all this sort of stuff. We don't touch that in the school curriculum, which is just crazy. So David's saying, if we teach this modern approach, and Viv, you'll pick this up at the launch, if we teach the kids this modern stuff, the kids will see the relevance of it to them and their world and be much more engaged. The other thing, from my own perspective, I think that a big barrier for when we introduce these more complex concepts to kids sort of from year 8 and 9, they get frightened off by it. Whereas if we introduce the language and ideas to them from a very early age, like we're doing, this will be much more familiar and they will be more inclined to be positive about science, rather than this incredible dip that you see in the attitudes to science. So putting the straight answer is, we are doing knowledge gain stuff, but we're also doing a simple attitudinal survey with the kids. And that's the basis of the research. Yeah.
Awesome. Thank you.
Good.
I love the activities. Kids are going to love them. I can just see.
Yeah.
And I think I'm a very much activities-based person, whether I be teaching early childhood, because at Botanic Gardens we get everything from early childhood to year 12.
Yeah.
But I used to teach secondary kids, college kids, but I've become more convinced that if you want to really get them in, get the engagement and get lifelong learning, the activities.
The activity is really,
and exciting.
Yeah. And unfortunately, that sort of excitement stuff has gone out of the science a bit for whatever reason. I'm not sure what it's
They banned a lot of the best experiments.
Yeah, well, that's true. Yeah, but one of the things that we're being a bit brave about is I mean, as a physical science person, I hadn't sort of fully appreciated the connections, the storyline that goes photosynthesis, sequestering carbon through photosynthesis to glucose, glucose shedding waters to produce cellulose, and then cellulose basically being the building blocks of the plant matter, organic matter, plant matter, and then of course the end of that is fossilizing that as coal and then burning it and sticking the carbon back into the atmosphere. So we've got a sequence of 4 lessons 5, 6, 7, and 8, I think it is, that you can just have a quick look at, where we've tried to get that storyline quite strongly for the kids. And we're hoping to get a couple of biology-based interns to help us if we can, get even in the little activities that we've got, if we can even enhance them a little more in the mid-year, intern break kind of thing, where hopefully we can jazzy them up even a bit more to make them. Because the combination of the physical activities and the digital animations and activity stuff that you can do now is just amazing. The simple glucose shedding water to produce cellulose is there's a lot of lovely little animations around about that allow the kids to sort of see it in the celery, but then also see it in a digital form kind of thing. Yeah. Any others?
So you're wanting to, in every state, make connections both with the education department and particular schools.
Yep.
That's the overall aim.
Yeah. And Viv, I wouldn't mind to use you and others from the list who have got connections to schools to get the word out about it, and then just ask people or invite people to contact us, and then we can just see how it sort of goes organically from there kind of thing. It'll happen. I've been in curriculum long enough to know that things don't just happen from the top down. People that you talk to that don't know how schools and teachers work think that some bureaucrat somewhere says, you're going to teach this, and then all of a sudden everyone dutifully goes out the next day and teaches that. It ain't like that. I mean, essentially, if teachers don't want to do something, they won't. And so we've got to win the hearts and minds of teachers right from the beginning. So we've got this sort of top-down, bottom-up kind of philosophy.
I'm very conscious at the moment of another COVID wave. There's high numbers of absentees in our schools, and a very tired, teacher population at the moment. I'm just sort of wondering how much of an onus is it, this would be a barrier, I think, for a lot of teachers taking on something.
Yeah, and I think that in like any change, I think it would be deceitful to say that it's not going to be a significant amount of work the first time through. I think but if I can just report on the year 3 teachers that have been doing the atom frenzy and hot stuff, they're finding that the engagement levels of the kids and the simplicity of the gear to start with and the little activities, but then the positive impact that's having on the kids and their learning is far outweighing the kind of the preparation that they need to do. The other thing I'll add is that we're trying to make it so that it's foolproof, really, so self-sustaining, and so as we can by having, we're working, like I've got a meeting on Friday with the modern teaching aids people in Sydney here to actually talk to about picking up the resources and packaging them within their normal catalogue. So, the teachers won't have to go any different from where they get most of their other stuff to actually work with. So that's the kind of strategies that we're looking at. Yep. Okie doke.
I have a question.
Yep.
It's Robin here, and I'm really sorry I jumped in late because I had to take the grandkids to swimming. But look, I think what you're proposing is fantastic, and unfortunately, I'm actually not a teacher. I work at the University of the Sunshine Coast in outdoor environmental education, and sort of looking at to put climate change education into outdoor education. But are you going to the National Environmental Education Conference and presenting there?
The answer is no. When is it?
Well, it's in September, and I think what you're proposing, should actually be, you should probably be the keynote speaker there, because we're in desperate need of.
I agree. You should be
talking about climate.
So where is it this year?
It's
Sorry,
in Newcastle.
It's in
Wollongong.
Okay, that's near. That's just south of here, isn't it?
Just a
I'm in
little
Sydney
bit.
today.
Yeah, that's south of where you are today.
Okay.
I think,
easy. Yeah.
I think, look, they've actually closed the call for abstracts, but I think
we could find a way.
I'm sure
there'd
be a spot.
Yeah. Look, if you can find a way, then that should be. Yeah. Because I've got a son and daughter-in-law are here in Sydney, so I can get down there very easily. So it's just a question of getting across. So if could find an airfare kind of thing, then I'd be more than happy to come across and present.
Because that would
there
really
you
help
can
promote it.
Yes, that would help promote it, and there you will find, your tribe, because it's not going to be seven people online here. It's going to be hundreds of people.
Yeah, no, that'd be terrific if we could. Yeah.
I'm not really sure. Look, I am involved in the A2E2 Queensland chapter.
Yeah.
But by no means am I the mover and shaker. But who's the person? Is it Viv?
Yeah.
Yeah, Viv, you seem like you're the organiser. Are you the organiser?
No.
I'm the immediate past president of ACT A2E2. I'm on the executive and also on the national executive.
Okay, so you're able to try to pull some strings there.
Yeah. Let's just see how we go. Talk to Jennifer, and then if we can work something out, then well and good.
Yeah. Look,
Robin, if it's any help, I'm the immediate past president of the national organisation, and I'm also on the committee. And David and I have talked about this, but he's so busy, he must have missed the time for it.
Yeah.
But there's certainly, this is why we offered the webinar, because it's a lovely way to get the information out, and we can now keep sending it out, so once we've got a video that can be shared, but really to see it in person, like the launch is going to be amazing, Viv, because David came out and did a session for us in WA with educators, and it was like being back in your science classroom in year 11, and you go, oh, I don't know the answer.
I love those photons.
That was such fun.
Photons.
It made sense, so
it's very simple and engaging.
And it's going to be amazing for teachers to take this up. It's just like Viv said, they're busy and tired, and how can you encourage them? But I'm sure if we can, and I love that idea, David, of inviting somebody to help you make a year-long program, because with the solid foundation of understanding, and then Laura, for example, works in helping people create projects, so they feel really positive about their impact on the environment. So to bookend a year for students, which says here, this is your basic knowledge, now make what is it you'd like to do with that? And plan to enact it. That makes a lot of
Yeah.
sense.
Oh,
I
good.
know
Very positive.
it's Robin again. I was chatting to Laurie Modi, who's head of Outdoors New South Wales, and she works with one of the universities there in the business school. Like each student actually has to do a project, so they sort of come to her as their industry partner, and that she gets those students to put in policies and legislations and work towards those sort of things. So I don't know in Western Australia if there's some opportunity with the university there to try to get some. So I think you're onto a fantastic thing. I think I don't know why this isn't actually taught in primary schools in Australia now. We're so archaic.
I think it's just stupid that it's, I've totally, the thinking always has been it's too depressive for primary school kids to deal with it. They've got to deal with it anyway.
See, like Viv, in the ACT, you've got an amazing sustainable schools network.
Yeah, well, that's what I was thinking.
And it would be so logical to, to go to that network and say, look, can you make the connections with this?
I think I'll ring up Angela and talk to her. She's the one who runs the sustainable schools. This is supported by the ACT government to help schools become more sustainable. So, we
she
probably
should go to the launch with you, Viv.
Sorry?
She should go to the launch with you.
I haven't talked to her. She wasn't at our executive meeting yesterday, so I don't know whether she is or not.
Viv, can I send you an email with the information about the launch so you can forward it on to her?
I've already done that, Dave.
Oh, you've done it? Okay, that's fine. Yep.
When is the launch?
David,
Sorry.
Can I just thank you for the presentation? I really enjoyed it. And as I already told you in the beginning, I'm developing educational material as well. The waste program is now being taught in many countries, so 20 countries in the world. So I have quite an extensive international network. So I mean, you're very settled in Australia, but we could also maybe expand this to other countries and other partners who already went through the legal, things that you were talking before. As well, because they are already teaching the waste program of Happy Green World, and we could collaborate in this and also provide more science-based to understand, what's climate change and sustainability of energy. So,
what's your email? What's your email?
That's info@happygreenworld.org.
info@happygreenworld.org. Okay, beautiful.
Yes. So let's see. I mean, good luck. We're exactly in the same boat. We want the same, and I think many of us on this call are keen to provide environmental education. And to me, it is going to happen because there's lots of demand, and that's what I experiencing.
Beautiful.
So it's gonna work out, and I would love to connect more, and then we'll see how we collaborate with all of us.
Good, beautiful.
Thank you very much.
Thank you very much. I have to go now. I'm on my way to work. So thank you very much, and goodbye to everyone.
Thank you, Malu.
Okay, bye.
Bye.
Okay, so just in light of this is the hour up. Not that we're going to be cut off, but we had offered an hour. Is there any other pressing questions, or we can share email addresses and keep the conversation rolling?
Yeah.
And I can catch up with the opening.
Beautiful. Yes. Viv, do make sure you connect with David Blair, particularly. You'll recognise him. He looks like the typical kind of physics professor guy. So you'll.
He's not Gandalf, is he?
Pardon?
He's not Gandalf, is he? No.
So David, you're going to be at the opening.
No, I'm not.
Oh,
I
you're not.
can't,
Sorry, I'm getting mixed up with the Davids.
Yeah, no.
There's 3 of them.
There's 3 of us. There's David Tregus as well. So
David
so it all
Blair,
gets a
David
bit
Tregus,
confusing.
David Wood. Yeah.
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 Beautiful. Look,
All right,
thanks
no,
for the
thank you.
opportunity. Yeah, thanks for the opportunity to chat. And certainly, if we can do anything about that national thing, then I think I would much prefer a workshop-y kind of thing, because the teachers actually get engaged, you know.
Yes,
I
they
think
do.
that, yeah.
It's that old story
Good.
of the practical hands-on,
Yeah,
and that's the
yeah.
best teacher. So, David, I'll connect with you after
Yep.
and link you to
There'll
the
be
program
engaged
team.
teachers there that I'm sure will be really interested
Yeah.
to
Great.
And
Beautiful.
David, I mean, from Queensland, we're going to have the Queensland delegation of A squared, E squared, and they're heavily involved in the local government here, the local Sunshine Coast Council, and the Sunshine Coast Council is quite like Marlborough Biosphere, so they're quite involved. We've got the Noosa Biosphere, the Great Sandy Strait, so 3 in a row to promote anything that can, enhance that biosphere.
Yep.
And obviously teaching a climate curriculum does through science. And there's always, we pay our environmental levy, so we can push the local council to hopefully even have a pilot school maybe on the Sunshine Coast.
Yep. No, that's great.
Wow.
Beautiful.
Fantastic.
Well, thanks.
And Emmanuel Luther in college is probably a good place to contact, because they actually have a sustainability officer at their school. So just write that, Emmanuel Luther in college on the Sunshine Coast, and they would probably be your #1 pick to go to. It's a private school, but
that doesn't matter. In fact, private schools in some ways are a little easier to deal with because you don't have the bureaucracy of the departments.
Yeah, and they've got that sustainability officer. So,
yeah. No, that's great.
Beautiful. Okay.
Excellent.
Okay.
Thanks so much.
Hope to see you at the conference.
Good on you. Thanks a lot.
Yeah, we just need to, he needs to find the fare to get there.
Yeah.
So I'm sure we can fundraise.
Yeah.
Okay. All right.
Good.
So thank you,
See ya.
everybody.
Okay.
Yeah.
We'll call it a wrap, and thank you all for coming.
Beautiful. Thanks so much.
Someone's dying in the background.
No, it's my
Thank
nephew,
you
my
very much,
grandson.
and we'll keep in contact.
Good. Thanks so much.
Thank
We'll
you.
see you. Bye.
Cheers.
Bye.
Bye.
Bye.